Greetings and welcome, friends. Mr. Waddy's here. We're going over this new concept called solving systems of linear equations by substitution. Yesterday, we learned our new strategy, our new tactic. So make sure you guys have your homework out. Be ready to ask questions if you need to. But otherwise, let's not distract our peers. So this isn't actually asking us to solve. It's asking us to analyze our strategy, Devin and Jamie. They ask, which of the variables would you choose to solve for? And when I'm looking at these, I've got two equations, each of them with two variables. Right, I actually have four choices to solve for, x's and y's. And the one that would be easiest to solve for is the second equation's y. Second equation's y. Why would that be the easiest to solve for, friends? Devin? Yeah, the leading coefficient is 1, so that would be the easiest to solve for. Any of the other ones, right, if I said solve for this x, I would have added y to both sides. And gentlemen, you can be quiet, please. Try not to do the squeaking. It's at the end of the packet. Middle of the packet, actually, this time. But eventually I would have had to divide both sides by 5, which would have created some fractions to work with. And then substituting fractions, it gets ugly fast. So the reason we do this is the coefficient is plus or minus 1, which means we could avoid fractions until the very end. So that's how we choose. Here, try not to do the squeaking, my buddy. My buddy, thank you. Gentlemen. So, 11. Let's do 11 together. So, step 1 in solving by substitution is solve one of the equations for one of its variables, which, notice, step 1 is already done. This equation is solved for x. All right, so here's the big substitution part. That happens during step 2. If x is really equal to 16 minus 4y, if those two things are truly equal, then they can be interchanged anytime I want them to. And so step 2 is that you plug in this expression for the other equation's x. And it makes the problem uglier at first. It looks crazy, but it actually makes the problem easier because the remaining outcome... Guys, focus here. Let's focus on learning. Try to stop the squeaking again. Jimmy, squeaking. You're like squeaking a lot. Sorry. All right. Well, now... Here, let's focus on learning this difficult skill. We'll go over it in a minute. So, when I plug in for x, you do have to plug it in parentheses because the leading coefficient of 3 there is going to have to be distributed. What was your question? I don't know the answer to this yet. I'm not worried about the answer as much as I am the process right now. Yeah. So now notice what this did for us. That actually leaves us with a single equation with a single type of variable, which even though it's a tricky one, it's one that we can solve. So guys, make sure you're writing this down. This would be a good idea. Follow along. No, answer is useless to me. Process is what matters for our friends. 12y and 4y, the negative 12y, if I combine those, is going to be negative 8y equals 8. How do I get y by itself now? Yeah, even though there's a minus sign right here, there's an invisible plus sign in front of that. That minus sign applies to the negative 8y. So let's see, this is going to be negative 40. And now what do I do? How do I get rid of that negative 8? All right, because that's being multiplied, the inverse operation would... Yeah, negative divided by negative will be positive 5. I like it. I like it. So that is half of our answer. Half of our answer. I need to plug this in to find the x. And the easiest place to do that is to do it in the equation that's already solved for x. And mathematicians, we folk be the efficiently lazy folk. I want to do the least amount of work, right, and get the most product from it. So x is going to equal 16 minus 4, and instead of y, I'm writing 5. 16 minus 20. I don't know what x is, right? I'm replacing the y with the 5 because I was just told y equals 5. So I didn't know what x was until I finished evaluating or solving that. So my answer is negative 4, 5. You could write that as an ordered pair. That's the combination of x and y that make both of these equations true at the same time. Graphically speaking, it is the intersection of both of those lines. All right, let's look at one more, and then we will continue our adventures. All right, step 1, solve one of the equations for one of its variables. So solve equation 1. Yeah, if I solve the first equation for x, I could divide both sides by 2. Sometimes that creates fractions, but in this case, it's not that bad. I also could solve the second equation for x because its leading coefficient is x. And yeah, we'll actually look at some of those ones today. I'm gonna choose the general strategy I gave that'll be friendliest most of the time. But since you guys tried it a different way, you should find out that it'll actually give us the same answer. So x, if we both obey the laws of math, we'll both get to the same answer. So if I want to solve this first equation for x, I got to move this negative 5y. How do I move it? Yep, add that 5y to both sides. So I'm going to get x equals 5y minus 29. So this is now solved for that. It's this is called a revised equation. And if x is equal to this, that means I can plug this into the other equation's x. All right, and I always have to plug it into the other equation. So if you did solve the first equation, you would be plugging your revised expression into the second equation, right? I solved for the second equation, so I'm plugging it in to the first. If you plug it into the equation you just solved for, you will come to a false conclusion where you will think there are infinitely many solutions, and chances are that is not the case. Maybe you get lucky, but you actually wouldn't have correctly come to the conclusion anyway. So let's see, 2 times, and instead of x, I'm writing this entire thing. Yep, 5y minus 29 equals 12. Make sure you remember to write the rest of the equation. Sometimes people get so pumped about the substitution part that they then forget to write the rest of the equation. And even though this is weird looking, the good news is that it's an equation with a single variable. Let's see. Those of you solved it the other way, are you thinking you're going to get the same answer as me? 10y minus, let's see, double 29. Double 30 would have been 60, so 58, I believe. Oh, I'm feeling that. Yeah, we're getting there. To now solve, should I move the 10 or the 58 first? If I try to move the 10, that's going to create fractions for me. Which is legal, it's just not fun, usually. So let's add 58. You're right. Yeah, it was easier because this one only had one equation, one variable. Yep, you're right, it was easier the other way. So let's see, now if I divide both sides by 10. All right, well, I can check yours out later to see where your error would have been. And if y equals 7, you could actually plug it into any of the originals or the revised. Any of them. It'll actually work no matter what. You were looking at the x. Yep. Yeah, if you solve the other equation for x first. What do you mean? I'm plugging this only in here, right? Well, that was a line from earlier. So 35 minus 29. And so x equals 6. Yeah. So I get 6 comma 7. So that is my answer. I think that's all I'm covering in today's homework video. But thanks for watching. Bye-bye-bye.